Well, I wanted to talk a little bit about this 3D printer, 8 Cup, and the components that make it up. What we have up here in the orange toolbox, the modified Homer toolbox, is the brains, the power supply, the electrical components that make it work. You notice the black ribbed hose comes down. That's where the actual wiring is routed in all throughout the unit, and the black sheathing hose. So we've got that's the electronics that make it function. Basically USB and motor controls is what it is. And here we have some of the filament. It's basically 1.75 millimeter PLA plastic filament that feeds down into a heated extruder that then pushes it out a small nozzle, and it builds layer by layer, moving the whole mechanism here moves up and builds layer by layer the item you want to print. It's all controlled by a computer. In this case, a laptop. Takes a CAD file, an STL file, and slices it up into layers and sends the commands to the electronics. And as it can take anywhere from a few hours to days to print something. You basically got 5 motors. You got this one down here. It's the bed motor. It's a fairly large motor because we're moving quite a bit of weight there. It runs a belt up underneath all the way to the back on this side. The belt pulls the table back and forth. We have the Z-axis motors, one here and one back in the back corner. They run in unison, raise this entire carriage up and down on these threaded rods. And then these are solid rods to ride along with it, so it's square. And those slowly go up, just increment up. This threaded rod. Then we have the X-axis motor, which is up here. And it's running the X-axis back and forth, and it's basically the same as the Y-axis, this lower bed motor. It's got a belt that runs, that pulls this little mechanism here back and forth that's attached to the rods, and it's just riding on these rods on open-sided bearings. Everything's done with these same open-sided ball bearings, linear bearings. And the extruder is actually fairly small there, if you notice, and it's just it's the 5th motor, which is the same kind of motor as the X-axis, but it's attached directly to a drive mechanism that forces the plastic through the extruder. And that's the basics of how it functions. And I've got fans on all these motors because they tend to run for days at a time, so they heat up. That's how it works. Everything works in unison. This moves back and forth this way. This moves back and forth this way, and forming the lines that's needed to make the part. Everything is done in lines. It's just going back and forth. An actual actually less than half a millimeter thick line that's forming this part. And it basically just builds it from layer to layer up. And the bed here is made of it's a bunch of aluminum with the bearings, the linear bearings. And we have the leveling mechanism, which is all the threaded rod you see, and that goes to a piece of steel steel plate. Then on top of that we have Corian. It's countertop basically. It's like a buffer between there and the bed. The reason that's there is because on top of that, underneath this green part you see, is a heater. It's a silicone mat, a 2-foot square silicone mat that runs on 110 volt, and it's capable of heating up to hot water, boiling water temperature in a few minutes. And it's got some wiring, so it needs to be embedded into the Corian. If you're wondering why everybody keeps seeing me do things with Corian and wood and stuff, that's why. I was using MDF before that. MDF's a terrible nightmare. It swells up so badly when it heats up, and then just warps. It was just way out of control, and it was just a terrible thing to use for any kind of bed material. I do not recommend using any kind of flake board or MDF for bed material. It's a waste of time. You're better off to get a piece of Corian. Even though Corian does start to flex at about 260 degrees Celsius. Around 260 degrees, it starts to flex. Boiling water temperature, right above that, it starts to flex. But in this instance, you've got enough support from the steel. It's not going to matter. It's not going to warp on you. It stays a lot better. Anyway, and on top of that, we have a 3/16 piece of tempered glass. It's kind of hard to get oven glass. Normally, a lot of the smaller printers will use oven glass, or what's known as porsilicate glass, because it's a lot flatter. It's got better properties when it heats up. But trying to get a piece like this size, a little expensive, so we're just using some tempered 3/16 inch glass for a topper. And then, of course, you've got the green painter's tape on top of that as a printing surface. Helps things stick to it. But, as you can see, you may or may not be able to see, the extruder is spring-loaded. I found that it works better for me to have it spring-loaded like that, just because sometimes you have issues where things aren't set quite properly and it'll crash into the bed. And this seems to give me a smoother finish, and it does quite well that way. It was part of the learning process for me, is why I spring-loaded it. It's just kind of stayed that way, but I've had no issues doing that. It's firm enough that it doesn't cause an issue. But admittedly, if I set the bottom stop wrong, which is that little gold-colored piece over there that sets the bottom stop, then if it crashes into it takes the crash. It won't hurt the head that way. It's just something I did, spring-loading the extruder, so that it does it. Some people spring-load the bed, but this would be kind of hard to spring-load the bed on this thing, being as big as it is, so I spring-loaded the extruder, which is kind of an opposite, and works quite well. Some other things, if you notice, the frame is made out of wood, and I want to stress this because people have watched me build this thing and work with it and try to make it work, and spent a couple years now making it work and getting it to this point. One of the reasons why it is what it is because it was done on an extreme budget. Basically, I did not have the money to dump into something this big to make it industrial, to make it, the best it can be. Sure, I would have built this all out of metal and aluminum and machined cast bed and all kinds of thicker rods and different kinds of rails and things, but I just could not afford that kind of cash flow. So this is built on a budget, and that's why it is the way it is, and that's why I've had some problems, because it was done on a budget, and I know that. So I've just dealt with them and made it work. Sure, if I won the lottery, sure, I would have something that was a lot better than this, and I would have built it myself, and it would have been just fine. It would have been a lot less hassle and a lot less problems. But when you do things on a budget, you have to deal with what you made. You do things the best you can. So, and you have to make alterations and do things a little differently when you're working on a budget. So, anyway, that's the gist of it. I got the base down here that I built. It's on wheels, easy to roll around. These are some of the tools I use. This is something I got from O'Reilly's Auto Parts store. It's a razor blade scraper for scraping the parts off the bed. Good for getting scrap up. And these are a pair of Jewelers tweezers. They have some sort of plastic fiber tip on them. I use them for cleaning off the tip to get the little extras off the tip of the nozzle. The nozzle is brass, so that's why I went with these plastic head tweezers. Because at first I was using metal-headed ones, metal tweezers, metal ends on them, and also needle nose pliers. I ended up messing up one of the tips because they're brass, and ended up damaging it to the point where it didn't print correctly, and it wore it out. So in order to stop myself from wearing out the tip so quickly, and this doesn't put any, doesn't hurt the brass. So, and these are about $10, but well worth it. They're a little tore up, but they've lasted a year now. So well worth getting a pair of these to take the little bit of extra stuff that squeezes out of the end of the nozzle off there before you start printing to kind of keep things clean. And that's what this is, a little catch-all for that kind of stuff. I have a bigger scraper I use, but that's basically all I use in tools. I do have the Allen wrench for adjusting the extruder, and I do have a small pair of clips I keep them back when I need to feed the new wiring. I really don't use many other tools now. Once it's calibrated and set, there's not much else I need for tools. At first I had more tools over here, but really no need for them. You probably have never seen this part, but you probably see it from the back side there, but these are pipe fittings that these rails are screwed into, and these rails were handmade just to save money, because they wanted outrageous money to buy a 2-foot rail like that. Would have cost $200 to $300, where I built 4 of them for probably less than $100. So, and I would have paid that much for one. So it's all on a budget. Everything is handmade. That's what it is. And everything's battery backed up. I have a battery backup down there, keeping it running. It keeps the extruder running and the motor's running, and it'll still print if the lights go out for a short time. That way, if the power flickers, I don't lose a print. I would recommend that to anybody. The battery backup there keeps you out of trouble. In case you have power flickers, especially in the winter, dead of winter, and in the spring. So, and I've put a meter on this, one of those kilowatt meters, to check how much power this thing actually uses. It all runs off of 24 volts. The only thing that's 110 is the bed heater. But all the motors and all the electronics are all off of 24 volts. It really uses very little power. Generally, it's under $1 a day to run a thing. So I can run a thing 24/7. It's less than $1 a day to run the unit. The bed heater does use some power, but I know the 24 volt side only costs about 40 to 50 cents a day to run. The bed heater uses a little bit more, but yeah, it's actually very inexpensive to run. Everything uses mechanical end stops right now. All my end stops, if you notice here, are mechanical. Even the Z stop, the bottom bed stop over there, Z stop. We've got some quick adjust on that. Some quick adjust lamp parts, and I can quick adjust the bottom stop to get everything lined up properly, because this wood tends to move a little bit depending on humidity and weather conditions and everything. It doesn't affect things very much, but very, very slightly. So sometimes I need to adjust that bottom stop just from day to day. And you've got some slop and things change, heat changes, different things change. So it's always a constant adjustment for that day. Usually day to day is, throughout the day is the same. But if you let it sit for more than a week and then try to start it up, you want to make sure you adjust that bottom stop. If you notice the linear bearings, I'm only using one on this side, and that was because of budget. There's 2 back there to keep things square, keep it from cocking on us, but that was due to a budget. I would have put another bearing there to get it even square, so there's less walk side to side on that. But again, it's a budget. So, and that's the way this throwing is. There's only one in the front, there's 2 in the back. Linear bearings, basically due to budget. I mean, linear bearings like that are $20 to $30 a piece. When you're talking, there's 30 of them here. I bought these for $7 a piece out of China, and that was bad enough on the budget. Sure, it can be done better, but there's a limit to how much money I'm just going to dump out on this thing. If somebody's interested, this entire unit was around $1,600. That's the base fee. How much I spent on it? About $1,400 to $1,600 base money. I've spent much more than that over the last year, getting things tweaked out exactly the way they should be. But the original cost was around $1,400, and with the heater and everything, it's about $1,600. But I've done a lot of modifications, a lot of additions, a lot of trial and error things that cost me hundreds of dollars, and they aren't even used on this unit any longer. But I probably have less into this than somebody would have into two of the small little printers, and even one of some of the smaller ones. Some of the little small ones run, $2,000, $3,000. The MakerBot is about $22, $24. This cost me right around, actually with all the experimentation and everything, probably I paid less than a MakerBot. So less than a MakerBot replicator at 2600, something like that. That's probably all I've ever dumped into this thing. So I don't feel bad. It's a big unit. It's 8 cubic feet capacity. You can see I've got cooling fans running through the electronics up there. There's a cooling fan on either end of that toolbox. Cooling fans on all the motors. I do have a dehydrator down there that I use, a convection dehydrator, to dry out some of the filament. I haven't found that too much of an issue. And I also found, I tried to use this, which is some Kapton tape, very expensive Kapton tape. I didn't like it. I don't like it at all. I really don't care for it. I'd rather go with the old painter's tape. I can get this about $1 cheaper a roll. This is out of Menards. I can get this about $1 cheaper a roll than I can blue tape. And another notation, Dollar General blue tape does not work. So I would not recommend Dollar General.